So here's a slightly trickier example. A small marble is rotating along the inside surface of a sphere at a constant speed v. The sphere has a radius of 1.3 meters, and the marble is rotating 50 centimeters below the center. Firstly, find the magnitude of the normal reaction force in terms of m, the mass of the marble, and secondly, show that v is greater than g over 2. So go ahead and try this problem if you wish, and then come back and see the solution. So here's the solution. Again, we have to find sine and cos of the angles. So we have R, our reaction force, acting perpendicularly from the surface. So I actually should have drawn that in. So this is acting perpendicularly, so that's a right angle there. So again, R will have to sit into components. So we get R cos theta acting inwards, and then we have an R sine theta acting upwards. Now, splitting this into components, the weight force into components isn't actually a great thing. It's just to show that in case we get to a situation like this in non-uniform circular motion, that the weight force actually has an act inwards on it. But for uniform circular motion, we only need to care about vertically up and down, not axial up and down. So it could be that R equals mg cos theta, but it doesn't really matter too much for now. We're just going to consider directly up and down like an xy plane. So we get R sine theta equals mg, so we have the perpendicular components of the reaction force. So we get R sine theta equals mg, so R is 13 mg over 5 newtons. Should have written my units in there. Now, of course, we're looking for the linear velocity, so the centripetal force is mv squared over r. So we have r cos theta, which is 12r over 13, equals mv squared over 1.2. But we know that r is 13 mg over 5, so we can put this in. And then we get v squared over 1.2 equals 12g over 5, after the 13s on this side cancel, and the m's cancel on both sides. So we get v squared equals 1.2 times this, which is 28.224. And then v we're given as 5.3 meters per second, which is indeed greater than g over 2 meters per second, because that is 4.9 meters per second.